Now that we understand design stages directly affect our corridor, you can see some different examples here that the state of Utah is using, and we've made some changes that I think are good from the examples workspace. For example, we made a copy of the number 2 design and we give it a name, design with external controls on. But I just want to go down here and look at some of these differences. The functional from the examples workspace and this new example is the same. But on preliminary, we've turned off external control points and densification of horizontal curves. On design, we did turn on horizontal curves densification and left off external control points. And then on this other design one, we do turn on the external control points. And then on final, everything is on the include of critical sections, but we are not turning on, for example, the meshes. And then the 4, 5, and 6, typically those are just for visualization, looking at your model. It's not necessarily something that you need to do for terrains or for machine guidance. There's other ways, better ways to create terrain models by using graphical filter definitions. Then the last one here is the final with linear features. This one sometimes is used to generate or to take a look at all your break lines, and then final components turns off your break lines, and again is more either for quantity calculations or visualization. But the focus here really is basically 0 through 3 here. I want to really talk about what we're doing with these settings. It's important that you understand what horizontal vertical cardinal points are, external control points, as well as densifications. Horizontal control points will essentially add an additional template drop anywhere there's a change in horizontal geometry. For example, the PC or the PT of a curve would be a good place or a good way to understand that you will get additional template drops set if that is set to true. The same thing with vertical cardinal points. If you have a vertical VPC, a VPT, a low point or a high point of a vertical curve, a change in tangency, whatever, you're going to see those additional template drops added to your model. External control points, the best way to explain this, say for example you're targeting a alignment that represents a wall, and you would, if you turn on your external control points, you're going to get at minimum a template drop at the beginning of that alignment and at the end of that alignment. You're also going to get template drops anywhere there is a bearing change or a PI within that alignment. And so your external control points evaluates those point control alignments you're using and adds additional sections. The densification of horizontal and vertical curves, this by far are two of the most important settings in terms of the accuracy of your model. What this does is it reads a configuration variable shown here, one for the profile and one for the horizontal curve. One of the changes that we're recommending is to change this to 0.1 and 0.1 instead of the default of 0.5 that is delivered with the examples workspace. This feedback came directly from a couple of major contractors here in the U.S. saying that 0.05 is just too tight, and they end up having to do a lot of data thinning to get the data into their machine guidance. They will even take these numbers as high as 0.2 and still have very accurate results out in construction. And so those are two changes that we are recommending for you to consider. And then on the design stages, just to kind of help with speed a little bit more, on the preliminary we're turning off control points, and we're also turning off the horizontal. And then on this second, these two parts of this design phase, one is going to be without the external control points turned on, and one is going to be with the external control points turned on. And then of course final we're going to leave as is in the examples workspace. And so I'm going to deliver this updated DGN lib and the updated configuration file on this wiki that has these design stage changes in there, and you'll just copy those over to your examples workspace, and that will go ahead and update them. Now should you already have a project started and you want to take on the changes, you'll see here in the civil standards under project settings in my file itself, you simply right click on the header of corridor design stages and just select update from library, and then it will adopt the changes that were made in the DGN library itself. I think that you're going to see with the changes that we've made to the configuration variables, also with the changes made to the corridor design stages and tweaking these settings on the critical sections a little bit, you're going to see much faster speeds on the processing of your corridors.